Okay, briefly, we interpret a couple of trapezoids and illustrate the statements made at the end of the preceding video clip. That area makes sense if the altitudes represent rates with respect to the width quantity, and that otherwise areas usually don't make sense. We have the first case where we're doing speed in miles per hour versus clock time in hours. We have this trapezoid representing 65 miles an hour at one time, 75 miles an hour at another, with a 3-hour time duration between the two. We conclude that the slope of this graph is 3.3 miles per hour, approximately, rounded to the nearest tenth. The average rate of change, and that is the average rate of change of speed with respect to clock time, since we're dividing the rise, which is the change in speed, by the run, which is the change in clock time. I observe that a linear graph here probably doesn't make a lot of sense, but if this is our speed at one time and this is the speed at the other, this is the trapezoidal approximation. Now, what actually happens to the speed of a car traveling down the interstate over a 3-hour period is probably not going to be linear. Could well be that we stay at about 65 miles an hour for most of the trip, and in the last 10 seconds just happen to speed up to 75 miles an hour. Or in the last 10 seconds, we could have hit the brakes and slowed down to 50 miles an hour or less. So that a rate calculated over this, unless we have some information that indicates that we did have an approximately linear rate of change of speed, or change in speed, that our speed was pretty much a linear function of clock time, might not have a lot of meaning, but that is still a valid interpretation, whether that interpretation has a lot of meaning for the trip or not. Okay, then we calculate the area, and the average of these two altitudes represents the average of the two speeds, which we would take to be an average speed. That would be 70 miles an hour, and we multiply that by the 3 hours, and we get average speed times the time duration. The DUR for duration is kind of obscure there, but that equals distance, and that's our interpretation of the area. So here's an example where we have the altitudes representing a rate of change of something, in this case position, with respect to the width quantity, which is clock time. In that case, we have a meaningful interpretation. Now here we have a case where this graph represents position as may be measured by the odometer in miles versus clock time in hours. So we can calculate the slope, 59 miles per hour, very straightforward calculation. The rise represents the change in position from 80 to 150 miles is 70 miles. And dividing that by the change in clock time, we get an average speed, 59 miles per hour, an average rate of change of the position with respect to the clock time. So change in position over time duration, or change in clock time, is the average speed. Now, if we take the average of the two altitudes, we get 115 miles, 80 miles, 150 miles, 115 miles. 115 miles makes perfect sense. That's where we are in the middle of our trip as measured with respect to distance. But then we multiply that by the 1.2 hours. In 115 miles multiplied by 1.2 hours, you can do that in your head, comes out 138 miles times hours. So our average position multiplied by our time duration is 138 miles times hours. But what does a mile times an hour mean? Cautioned you before, it doesn't mean miles per hour. That would make no sense at all in terms of the other quantities involved here. You could think about that. Don't know what that means. And it turns out that it's pretty much meaningless. And I also observed that if this is, let's say, your trip mileage on your odometer, your trip mileage could have started any place. It could have started at 30 miles and ended up at 100 miles. You'd have still had a 70-mile change in position, which divided by the 1.2 hour change in clock time would still give you 59 miles per hour. This quantity is independent of where your odometer happens to be when you start. Okay, this quantity is not independent of where the odometer started. It's completely dependent on it. If you started at 30 and ended up at 100 miles, you would have had a completely different result here. Or if you started out at, let's say, 850 and ended up at 930 miles, that would have changed this quantity completely, which is another indication of how meaningless that quantity actually is. So, summarizing, the first example, speed is rate of change of position with respect to clock time. I left off the clock just because of running out of space. So the area was meaningful. In the second example, position isn't a rate of change of anything with respect to anything. So the area isn't meaningful.